Hey, a while back, I was playing a game called Visual Memory on a website called Human Benchmark. The goal is to memorize and then replicate an increasingly complex pattern of squares on a square grid. It's practically the same thing as the Simon memory game, but instead of memorizing a sequence, you have to memorize a pattern. And while I was trying to beat my high score, I asked myself a question. Could I recreate this game in Minecraft using only redstone? The first step was to list the core principles of the game in order to have something to build upon, and after an efficient session of brainstorming, here's what I ended up with. First and foremost, the display is an n by n square grid. The game unfolds in rounds, and each round is made up of two phases. Firstly, some squares flash white for about 1 second in a random pattern. Secondly, the player has to replicate the same pattern by clicking the right squares. If he makes 3 mistakes in a single round, the player loses one of his 3 lives. The game ends when all 3 lives are lost. During the first round, 3 squares flash white, then 1 more in each subsequent round. That's 4 squares in the second round, 5 squares in the third round, and so on. The grid grows in such a way that always less than half the squares flash. Otherwise, the difficulty wouldn't be increasing anymore, because the player could memorize the increasingly simple pattern of the non-flashing squares. The score is determined by the number of rounds the player has successfully completed. In order to recreate this game with redstone, I had to make some compromises. Thus, I decided to go for a fixed difficulty, since it was too complicated to make a display that kept changing. But that made the game way easier, so in order to compensate, I deleted the 3 lives, which also made the redstone simpler. Now that I had a clear plan, I could finally start building. Before we start, just a quick note. I will now be calling the squares lamps, since I used lamps as the squares in my build. The first thing I needed was a way of creating random patterns of 7 lit lamps on a 4x4 equals 16 lamp grid. I initially thought of building some kind of pattern library where I would store verified patterns, but that would have significantly cut the number of patterns to play with. I then thought of giving each lamp a 7 out of 16 chance of lighting up, but then the number of lit lamps would be somewhat random. After a lot of thinking, I ultimately found a solution utilizing signal strength. In case you don't know, when a comparator is facing out of a container, it emits a signal strength based on the fullness of the said container. For instance, an empty container leads to a signal strength of 0, whereas a full one outputs the maximum signal strength 15. Based on this principle, I filled 16 shulker boxes at different levels, so that each of them would correspond to a specific signal strength between 0 and 15. I then put all of the shulkers into 2 droppers facing into each other, allowing me to shuffle the shulkers. I could then draw 7 random shulkers corresponding to 7 lamps, and that fixed every previous issue I had. When that was done, everything else went very smoothly. I converted the hexadecimal numbers, signal strength, into a 4-bit binary number, which I split into 2 separate 2-bit coordinates that I could use to map the shulkers to the lamps. Next, I added a memory to keep track of the selected lamps while the pattern is forming, since the lamps are selected one by one, not simultaneously. I also added a write function, which essentially allows me to choose when to write to the memory. This is very important because while the computations are running, some lamps that are not selected can seem to be, and those fake informations shouldn't go through to the memory. I then added another write function at another memory, but you'll understand why later. This last part is clearly my favorite. I just think it's so clever. What I needed was a screen that could display a pattern while also being able to handle player inputs. However, in this type of build, there's very little room, and that imposes constraints. In a memory cell, you can only write from one side, and the other side is used to clear it. But that's when I had a brilliant idea. Instead of writing from the back, I could write to every single memory cell from the front, and then clear the non-selected ones from the back based on the pattern stored in the first memory. That way, I could display the pattern onto the screen and still be able to write from the screen to the memory. But then I ran into another issue. In order to clear the screen, I had to clear the whole memory. Thus, after displaying the pattern you have to memorize, the computer would instantly forget it ever existed, and that's not what we want. That's why I added the second memory, so I could clear it and still have the pattern stored in the first one. At this point, the core was fully functioning, but I still had to press the write and clear buttons manually, and all the redstone was exposed. So I quickly added some basic clocks and timings and logic gates, as well as a nice user interface with lose, win and loading indicators and a score tracker. I did some debugging, multiple tests, and then it was done. I did it! As a conclusion, I would like to thank Mattbatwings, whose amazing redstone videos have inspired me not only for this video, but also for many other projects. I especially enjoy his Logical Redstone series, which made me discover a lot of very interesting concepts and methods, some of which I have used in this build. I don't think he will see this video, but in case he does, Mattbatwings, I hereby challenge you to recreate this game yourself with redstone. I'm sure it's gonna be way better. If you've enjoyed this video, consider subscribing, and maybe one day I can outgrow Mattbatwings as a channel. Bye.